Yeah, so good morning, everybody, and thanks Adalberto for the introduction and the invitation to give the opening keynote here at this year's SUI conference. I slightly changed the title of my talk, so it's not supernatural only. We have two more S, and I will tell you a little bit about these two S later during the talk. So actually, I initiated this symposium about 5 years ago, in 2012, together with Wolfgang Stürzlinger and Evan Zoomer. And the goal was to set or start up an ACM event which is focused on spatial and 3D user interfaces, since we assumed back at that time that those interfaces will get more and more important once technologies such as AR and VR are going to be widely accepted and widely available. And today I would like to give you my perspective on what I think is important when developing interfaces for such immersive technology. So as you know, immersive technology allows us to dive into a computer-generated world. You can do that either by donning on a head-mounted display, by putting on some 3D headphones, or maybe using some haptic devices. And in contrast to non-immersive technology, such immersive technology really makes it easy for humans to feel a sense of presence, so that you really believe that the computer-generated environment that you observe is really existing. And according to Slater, this sense of presence has multiple dimensions, and in particular two illusions which get evoked if you use, or which might get evoked if you use immersive technology. The first one is place illusion. So this is the illusion which denotes the situation that you believe that the space that you virtually observe is really real. And this is like the very classical virtual pit experiment I think most of you also have in your labs. And this is not only a subjective feeling, but we can also measure it on biometrical data like increased heart rate or skin conductance. The other illusion Mel Slater refers to plausibility illusion is an essential aspect of sense of presence as well. So the plausibility illusion denotes to the illusion that you think or believe that the events which you observe in the virtual environment are actually occurring. So for example, in this situation, you might really think that you are at the bottom of the ocean and you really have the illusion that this whale is really passing by. And this is, by the way, an installation that you can see in the National History Museum in LA. And I think another very important aspect of the sense of presence is social presence. So social presence describes the illusion that you actually believe that the virtual characters which are there with you in the computer-generated environment are actually there with you. There might be virtual agents or there might be virtual avatars, as in this Facebook example. And just to also frame a little bit better the technology I'm going to talk about today, I would like to reference here Milgram's virtuality reality continuum. He used this line, and in both ends we have either the physical reality as we know it and as it surrounds us, and on the other hand, the completely computer-generated environment called the virtual reality. And now depending if you either add some virtual information to the real world, this will bring you to the augmented reality area, or if you add some real information to the purely computer-generated environment, this brings you to the augmented virtuality. And the entire space between these endpoints is referred to as the mixed reality. And Fred Brooks defines some very interesting requirements for virtual reality environments, and I think those can also be applied to mixed reality in general. So he said, like, what you really need for a virtual reality environment, or in this case a mixed reality environment, is real-time rendering. That means as you change your head, your viewpoint in the virtual world should also change. The other one is you need real space, according to Fred Brooks, and it could be concrete or abstract, that doesn't matter, but it has to be three-dimensional rather than simply having 2D head-up displays. And the last one is real interaction, so you should be able to really interact with the object displayed in the environment. And this kind of taxonomy or definition helps us also to distinguish, for example, a purely 360 video from virtual reality, since you cannot really interact with the objects displayed in the video, and you can also not really change your position if you don't have head tracking here. And here are just a couple of consumer products currently available, which are more or less in one of the areas of the mixed reality continuum. So here on the right side, we have the big three of head-mounted displays, allowing you to immersively dive into a virtual reality environment. On the far left side, we have technology which allows us to reconstruct our real world based on 360 cameras or light field cameras. And in between, there is more or less technology which allows for optical see-through or video see-through augmented reality or augmented virtuality. And from a technological standpoint, the first mixed reality displays were introduced already back in the 60s. So I'm really curious, how many of you know this gentleman? Can you please raise the hand? So probably you have seen him a little bit younger. So this is Ivan Sutherland. Ivan Sutherland, one of the creators of computer graphics. And in 1965, Ivan Sutherland wrote his wonderful essay called The Ultimate Display. And in this essay, he speculated what an ideal, optimal computer display would look like. And he concluded that the ultimate display would, of course, be a room within which the computer can control the existence of matter. And he gave some examples what that means. So he said, for example, a chair displayed in such a room would be good enough to sit in. Handcuffs displayed in such a room would be confining, and a bullet displayed in such a room would be fatal. Guns, bullets, handcuffs appear to be very unsettled items for the ultimate display, but he also wrote that with appropriate programming, such a display could literally be the wonderland into which Alice walked. So the ultimate display would be a computer-mediated reality which would get indistinguishable from the real world. And this notion of a virtual reality environment is often used in science fiction to question whether we truly know if our perceptions are real or not. And movies like The Matrix, directed by the Wachowski siblings, is probably the most prominent example of our generation of this kind of perceptual ambiguity. Actually, the notion that our real world is just a computer simulation has been shown the first time in the German TV show called World on Wire, Welt am Draht in Germany, directed by Rainer Fassbender in 1973. How many of you have seen this movie? So not too many. So I have a copy at home. It's a very boring, very lengthy movie, but at least some of the snippets from the movie you can use in presentations. Already 5 years before this movie came out, 3 years after Ivan Sutherland wrote his wonderful essay, he was able to build actually the first prototype of what we would consider today as a mixed reality, or in this case, augmented reality display. And this is original video footage of Ivan testing this, what was later called the Sword of Damocles. So you can see this link cable at the top, which is essentially important for tracking the position and orientation. And the display itself was more or less like beamer technology or beam splitting technology, in which you had like transparent screens on which you project, in this case, a very simple wireframe cube in space. And of course, now we have all the essential aspects on a mixed reality environment, so you could basically, for example, change the position in order to get a different perspective of the wireframe. And the interesting thing is, just by changing the perspective, the wireframe cube might get outside of the view frustum, which also explains why Ivan Sutherland was so interested in clipping approaches, because that's an essential problem if lines get kind of partly out of the view frustum. So this was in 1968, and it always fascinates me to see what other technologies have been launched exactly in the same year, 1968, or maybe half a year earlier. So, and I would like to briefly go through them because they all had a huge impact on human-computer interaction and the interface paradigms that we use today. So how many of you know this person, Doug Engelbart? So that's the inventor of the mouse. He gave a demo in 1968, which was later called the mother of demos. And he basically developed the mouse, and which was later on built by Bill English. However, from there it took a couple of more years until actually the first computer came out which actually made use of the mouse. So 5 years later at Xerox PARC, the researchers developed the Xerox Alto, which was kind of the first research prototype which actually made use of a keyboard in combination with a mouse and had a graphical user interface which actually could exploit the advantages of the mouse. It took a couple of more years and before there were certain commercial products coming out. One was the Xerox Star, which was launched by the Xerox System Development Division a couple of years later, but it still took about 10 years until the mouse and the graphical user interface really skyrocketed and became the ubiquitous interface for human-computer interaction. So the first commercially successful product at that time was the Apple Macintosh, which was the successor of the Apple Lisa. And what we observed from there on is that graphical user interfaces, mouse and keyboard, were the primary way how humans interact with computers. So what we saw is a change of the paradigm how we interact with computers. Back in the 60s, the dominant interface paradigm were command line interfaces in which computer scientists or engineers use strictly commands in order to interact with the computer. The introduction of the mouse and the keyboard allowed now to use graphical user interfaces, and now the mouse was kind of the primary input device. So less known from this time is another technology which also came out in 1967 and which is pretty dominant in the way how we interact today. So historians generally consider the first finger-driven touchscreen which has been invented by Eric Arthur Johnson in 1967, and actually he was here in the UK at the Royal Radar establishment in Melbourne. And what you see here on the bottom part of this display is like the essentials of capacitive touch technology that we have today. And again, it took a couple of years until those made it into commercial products. The first, what we would consider today as a smartphone featuring touch technology, was the Nokia 9000 communicator. There have been some other devices before which used touch screens, but they haven't had really internet connection, so they could not really be considered as smartphones as we know them today. And I assume most of you are familiar with what happened in 2007 when Apple launched the iPhone 2G, respectively Edge. And from there on, essentially all our currently smartphones use multi-touch technology as the primary input. And again, we observed a shift in the paradigm how we interact with computers towards so-called natural user interfaces. So we are currently now in the process where we get rid of the mouse and the keyboard and essentially use our finger for touch interaction, for gestures, and more speech when we interact with our computers. And this transition from graphical user interface to natural user interface really makes sense if you consider the roots of the graphical user interface metaphor. So when you assume around the 80s or 70s, when did users get in contact with computers the first time? This happened in an office environment. And from this perspective, it totally makes sense to use these metaphors that we have in graphical user interfaces, like the desktop metaphor. So if you want to explain to somebody how does your computer work when they see a computer the first time, you could easily say, look, this is just a digital extension of your physical desktop. And you have the same metaphors here. There are icons, there are folders, there are files, there are records. And so it's very intuitive for users to interact with these kind of environments. But the world is changing. And the question is really if this office assumption is still valid today. And we see that users get in contact with computers way earlier before they get their foot the first time in the office. And I have a two-year-old son by myself, and for him, of course, files, records, folders, these kind of metaphors doesn't make any sense. He never has visited an office so far, but he's still able to use some sort of computer technology. So let's come to the next paradigm shift. I showed you the video of Ivan Sutherland earlier, again, 1968, so all around the same year. And from there, it also took a couple of years until we saw the first commercial products coming out. So this was VR in the 90s. There was also an enormous hype around this technology, and the VR technology received a lot of media attention, also addressed in science fiction literature and cinematography, which brought this technology to the broader public's attention. This was also the time when I got in contact with VR the first time. As a young teenager, I went to the Cyberspace Cafe in Berlin. And the cafe featured amusement cart style machines from W Industries. W Industries was named after Jonathan Walden, which I think was also a UK person. Later on, the company was called Virtuality. And in this cafe, I was able to play my first game of Dactyl Nightmare. So I'm wondering how many of you have played Dactyl Nightmare? I think there are a couple. Cool. Yeah. So you remember this time, there were like these checkerboard, Escher-like world in which you had multiple platforms which were connected by some kind of moving stairs and moving platforms. And you could use your head-mounted display and a controller to move around in the space, and your goal was to hit other players who were there with you and also fight the dragons which tried to catch you. And although the quality was really low, this game really blew away my mind. So I really had all the illusions that were later described by Mel Slater. So I really had the illusion that I am there in this Escher-like world. I really had the illusion that the dragon tries to catch me, and I really had the illusion that my friend is there with me in this environment, fighting together, trying to get the dragon. There were also some consumer product launched in that time. Nintendo tried to bring the Virtual Boy to the mass market, and it was a total disaster. So this was a red monochrome head-mounted display. There were about 20 games that you can play. And just as a reference, I think in Japan they sold about 700,000 of those, just compared to the Game Boy with 100 million just in Japan. So this is a video snippet of the Virtual Boy. Does anybody of you still have a Virtual Boy? Okay, so they're getting more and more expensive on eBay. So this is what the game looked like. So it wasn't actually a 3D environment. It was more like a set of 2D images which looked prospectively as 3D. But the problem, as you can see, is whenever you try to immerse somebody back in the 90s, you could only see a few colored polygons, low resolution, inaccurate tracking. There were a lot of drifts and unacceptable latency. And, well, VR never made it to the mainstream back in the 90s. And the problem was that the entire technical milieu for VR was missing for a compelling VR experience. VR was still very expensive, very bulky, and unusable. And VR's that became the common narrative back at that time. So, and probably many of you have observed the same whenever you taught somebody or talked to somebody that you're doing VR, this was kind of the phrase that you heard then, well, VR is dead, it doesn't really work. And it turned out that around the millennium, virtual reality was not the way how humans interact with computers. The real revolution came in a different form factor, which was just small enough to fit in your pockets like the smartphones. And it's really interesting, or almost ironically, that the resurgence of virtual reality is based on technical advancements which were made in the smartphone market. Because all the most essential components that we currently have in our head-mounted display are based on advancements from the smartphone market. Might it be the OLED screens or LCD screens, the IMUs, the gyroscope, the GPU performance. These are all essentially coming from the smartphone market. And the ultimate displays of today look like this. So these are the big three that we currently use. They're still not ultimate and they're still not optimal. There's still a lot of things that we need to do. But whenever I try those, you really get a glimpse how the ultimate display might look like in a couple of years. And here are the same for the augmented reality market. And I just plotted the Google Trends, and you can see like this exponential behavior of virtual reality. For augmented reality, you have the two peaks, which are kind of really surprising. And if you just think about where these peaks come from, on the left side you have the Google Glass launch, and here on the right side you have the Pokemon Go launch. And this is the Gartner hype cycle from July 2017, so the most recent one, and it's not surprising that the two technologies I'm going to talk today about, virtual reality and augmented reality, are those technologies that they think will make it to the plateau of productivity within the next 2 to 5 or 5 to 10 years. And all the business predictions that we have seen in the last years are like super optimistic, maybe a little bit too optimistic. However, this is a prediction from 2015 from Capital, and they were pretty accurate for 2016. If they're still valid for 2017 and the following years, I doubt a bit, but at least for 2016, this was almost correct. And today we have more than 100 million people in the world wearing some sort of head-mounted display, most dominantly, of course, the cheap and inexpensive Google Cardboard-style displays, but also the more advanced head-mounted displays had a quite good turnout in 2016. And currently, I would say all industries, companies, and economies try to find and explore ways how they can use VR and AR for their business. And I guess that most of you also work in certain areas here. And so we are, again, at the border to the next paradigm shift. And that's why I really like this name of this conference, because it kind of fits very well, at least what I want to talk about. So I think that despite the touch, voice, and gesture that we have so far, these new interfaces are going to be more multimodal. And I think this new paradigm might be more spatial, more supernatural, and also more smart. And if you consider these paradigms shift that we have observed in the last 60 years or so, we see that the time and cognitive effort that humans have to spend or devote to get the machines to accomplish their tasks is steadily shrinking. And it's also important to notice that these other paradigms do not really disappear, but it's not the primary way how we interact with the computers anymore. And I bet there might also be a lot of cases in the future where we still use graphical user interfaces and in which we still use natural user interfaces, but I bet that the dominant way how we interact with computers in the next decade or so is going to be more like illustrated here in a more spatial, more smarter, or supernatural way. And the remainder of my talk, I would like to talk about these three aspects, so the 3S of SUI, although SUI is the acronym only for the spatial part. I would like to give you a perspective of what I think these essential aspects will be in the future. So coming to the first part, which is the extension of the natural user interface paradigm to the supernatural user interface paradigm. So first of all, we need to understand or think about what is actually a natural user interface. And again, I'm always trying to get some inspiration from science fiction. And here you see in a lot of science fiction movies that the actors are able to perform gestures in midair and in free space to interact with visually impressive 3D user interfaces. However, although these interfaces look really impressive, there has been a lot of research dedicated to evaluate these kind of 3D interactions, and Rob Tether and Wolfgang Stürzlinger have done a lot of Fitts law tasks, for example, to identify how effective are we when we interact in a 3D space. And as it turned out, in most situations, actually, the mouse is still in the overall performance a little bit better than all the 3D input devices that we use for interacting in a 3D space with floating objects. And there are a couple of reasons for that. First of all, the missing haptic feedback, if I'm kind of doing some mid-air interactions, introduces some jitter, which leads to more errors, to less inaccuracy, and also overall more errors in total. But most importantly, I would say that mid-air interaction is really exhausting. So whenever you try to interact in mid-air for a minute or something like that, you will see that your arms begin to feel heavy and oversized, which is known as the gorilla arm syndrome. And this is not the way how you want to interact like on a daily working basis of 8 hours. The other very interesting aspect of these interfaces is that some of those interfaces are claimed to be natural. And I wonder how many of you have access to the HoloLens, our HoloLens in your lab. Is anybody from the Microsoft HoloLens team here, by the way? Okay, so I can use my next sentences. So many of you might have observed that if you give a demo of the HoloLens to a new user the first time, you have to explain this bloom gesture or the air tapping gesture. And again, the bloom gesture might be a little bit more simple, but the air tapping gesture is really something which is unnatural to users. And you really have to explain how they have to do that. Sometimes you have to hold the fingers for them and show them just knock down the finger or so. And of course, I understand why this gesture is beneficial for the HoloLens, because the inside-out tracking of the HoloLens is very good in detecting this gesture. On the other hand, this is really not a natural gesture. Well, it might be if you're a chain smoker, but for like ordinary users, this should not be like a natural gesture that you perform on a daily basis. So it seems like that these interfaces are not really that natural. So the question arises, what is natural then? And in my group, we thought a little bit about that, and we came up that we thought, okay, it should be something that you learn, even if nobody teaches you to do so. And so we were considering, so what does a kid, like a 1-year-old or a 2-year-old, what do they learn, even if I do not tell them how to do that? And it turned out that they're actually pretty good in doing some stuff. So I have a 2-year-old son now, and he's pretty good in just grabbing stuff. And he also started to walk, or he points somewhere. And I haven't really taught it to him. He naturally started to walk, to grab things, to bump stuff into each other, etc. And as it turned out, actually researchers from the Northwestern University in Illinois performed studies that indicate that the infant brain comes equipped with something they called intuitive or naive physics. So they have a basic understanding of very simple and physical laws. For example, they have a good understanding that unsupported objects will fall. They still try and do all the time, just to tease us, but they have this understanding. They also have a good understanding of spatial memory. So if you hide something somewhere, they will naturally understand where these objects are and will remember those. So, and that's why we thought that it might be a good idea to develop natural user interfaces which are based on these intuitive physics or naive physics. So it should be able for a user who only knows about pointing, grabbing, touching, walking to interact with such a user interface. So it seems to be a good idea to use this natural mechanism, but since we're in the virtual world, we should not limit ourselves to this physical reality. So the idea would be to develop user interfaces which are based on these very natural mechanisms, but we can enhance them with a little bit of magic. And this brings us to at least my definition of supernatural user interfaces or magic user interfaces, which are natural user interfaces, which are not limited to physical reality. And I want to give you one example of how this could be implemented. So let's revisit the last sentence of Ivan Sutherland's wonderful essay, The Ultimate Display. And he concluded with saying, with the appropriate programming, such a display could literally be the wonderland into which Alice walked. So the main idea of this sentence is that users should be able to explore the ultimate display in the most natural way, which is not using a mouse or a keyboard or any joystick device. It should be real walking, so you should be able just to walk through your computer-generated environment. And actually, it turned out that this is quite simple in virtual reality. This is one of the requirements of Fred Brooks, that you can just change your viewpoint in order to get a new perspective of the environment. So you can just map all your motions in the real world one-to-one to motions of the virtual environment. However, there is an essential problem that actually the real environment in which you can move around, like your lab space or your living room, which can be tracked by the sensors, is usually smaller than the actual virtual environment which you want to explore. It might be an architectural model or an entire city model. And the problem is usually you wear some kind of immersive technology, so you're not aware of your physical limits. So while moving around in your laboratory environment, it might be that you're not aware of, for example, physical boundaries that you have, and at some point you might crash into a wall. And these things really happen, in particular nowadays, in situations in which you do not have these very strict research protocols, in which you have ethic approval or controlled environments, but basically outside at people's living room. And here's just one video from YouTube in which you can see a female user who is perceiving a high sense of presence while playing a zombie game. So she really believes that she's there in this strange city environment, that there are really zombies running behind her. And see what happens.
You almost go get the knife. Oh, shit.
So these things really happens nowadays, right? And I'm really I'm surprised and still lucky that not really bad things happen yet. So there is one concept how you can try to address this issue of a limited physical space, which is called redirected walking, which has been introduced by Sharif Razak from UNC at Chapel Hill. So let me illustrate the main concept. So this is a user, for example, in some kind of living room environment with a real door and a real chair. If the user now dons on a head-mounted display and assume that the virtual environment just displays a virtual chair. So in this virtual environment, the user might now walk around in a one-to-one mapping. However, there are some problems. For example, the user could not sit in this virtual chair because there is no physical support here, so the user would just fall down. However, if we can predict that the user wants to go towards this virtual chair, instead of using a one-to-one mapping, we can slightly rotate the environment while the user is walking towards this chair. And by doing so, we force the user to walk on a circular path in the real world, which is illustrated here. On the same time, if this manipulation is small enough, the user is not aware of this manipulation, and he or she actually believes that he or she walked on a virtual path, which was a straight path. And the interesting thing is, by this rotation, we can also shift the location of certain objects. For example, the virtual door is now shifted away from the actual physical real door. And more interesting, the virtual chair, which was at the top left at the beginning, is now co-located with the physical chair. So the physical chair might provide some passive haptics for the user so that the user is actually able to sit in a chair which is not good enough to sit. We have performed a series of experiments now to try to identify how much we can actually trick the user. And as it turned out, in our experiments, which are already like 5 years ago, we found that you need about a radius of 20 meters in the physical space so that users have no chance to detect if they are manipulated or not. And these experiments have been replicated by our group and other groups a couple of times. And as it turned out, with the increasing quality of the head-mounted display, the radius which is required to guide users is getting smaller and smaller. So it seems like that we can manipulate the users even more the better the quality of the visual display gets. And this kind of makes sense because you introduce a conflict between the visual sense and the proprioceptive and vestibular information. And the hypothesis is the better the visual quality of the head-mounted display gets, the more you trust these cues in the multisensory integration process, and the less kind of you trust your proprioceptive and vestibular information. And nowadays, we can actually, and this is shown last year and also this year, around a radius of 10 to 11 meters would be sufficient to guide you on a circular arc so that you're not able to observe that. So this was one example of supernatural user interfaces, which are based on the most natural way of moving through the environment, which is walking, but enhance them with a little bit of magic to limit this constraints of physical reality, like a limited space in which you can walk. And of course, there are several other natural or supernatural interfaces which you can use. And here are just a couple of videos from things that we do in our group. You can fly on dragons, of course. You can fly like Iron Man through the environment. You can use multiple hands to interact with the environment, just exactly at the location where you need them. Or, for example, you can enhance or augment your vision so that you're able to see, for example, heat or Wi-Fi signals and so on. So this brings us to the next aspect, to the second S, so to say, of SUI, which is the spatial dimension. So spatial user interfaces, that's the core of this symposium, and make use of the space surrounding us to interact with technology. And the space surrounding us can be categorized using different approaches. This is a very famous one by Edward Hall, which introduced this taxonomy to distinguish the space between intimate, personal, social, and the public space. And I assume that all of these areas are going to be used in spatial interaction. However, there are also some very interesting observations. For example, how many of you have played with a Wii controller? Okay, it's almost all of you. How many of you have played tennis? So if you play tennis, like at the beginning, you are like really excited and really motivated, and you start playing tennis like using your full physical body, and you really play it as you would play it in the real world, and it's really fun. It's fun for about 10 or 20 minutes, maybe an hour or so, but then at some point you realize that the IMU in the system also works if you just do this. And from there on, it's really hard to continue playing like this if your opponent is just sitting next to you on the couch and is just beating you and being just way more efficient. So humans seem to be lazy, and there is actually some research indicating that. So locomotion researchers from the Simon Fraser University in Canada have found that the subconscious nerve system continuously fine-tunes movements to keep the energy costs low. So it seems that humans are wired to be lazy at some point. And I think this is an information that we should use some sort in order to make our interfaces maybe a little bit more comfortable, a little bit less fatigue, and a little bit less energy expensive. So here are a couple of approaches how this could be addressed nowadays. So for example, with spatial user interfaces, you can use touch, which gives you support, which is kind of more comfortable than doing interactions in space. If you do, like here in the center part, interactions which are in mid-air, like hover gestures, etc., you should think about to make them just very briefly rather than having them exhaustingly in the space. And I think Alex Schwartz will talk a little bit about the spatial user interaction and how he designed those in such a way that they're more intuitive and not so exhausting, like using these kind of brief interactions rather than having extensive long interactions. Or if you do some interactions in free space, you should also use some sort of devices which make things more comfortable, like allowing user to rest their arms, for example, for some spatial interactions, etc. And I think also another very interesting approach for spatial interactions is making the space in which you interact a little bit smaller, using, for example, micro gestures by taking advantage of some of the micro sensor technology which is currently available. And here is an interesting work which has been presented at the CHI conference last year by Desney Tan's group from Microsoft Research, which is called Finger.io. And the idea is here to use sonar technology for example, which is built in your smartphone or in your watch in order to detect the position of your finger, for example, on your skin or somewhere else. And there is a lot of research which has already been done in the last couple of years exploring these kind of micro gestures. And there is already available a taxonomy which tells you what is the most intuitive and natural way to either use one hand for micro gestures or use your two hands in combination for certain kinds of micro gestures. And if you just think about driving in a train or in a bus wearing maybe a Google Glass device or the HoloLens or some immersive technology and think about interacting like this way of tapping on your glasses compared to these micro gestures which you just do basically in your pocket or on your hand or on tipping on the fingers, it seems that these micro gestures have a better chance to get accepted in public and are just less energy efficient, or they're more energy efficient. And there's also an interesting thing that you can observe if you think about the spatial interaction and the space that you use for the input. So what you could observe from the different paradigms going from command line interfaces, which were the dominant way of computer centers in which you just had big machines and had to run around to get from one machine to the other, then to graphical user interfaces in which you still had a desktop and a chair and which occupied some space of your social space, to natural user interfaces which are mobile and which are in the range of your personal space, to maybe SUI interfaces which make use of your intimate space. And you wear those technology basically on your body, and basically as a smart watch, for example, as glasses, etc. And again, here are some examples of our group. The bottom left you have seen already, which kind of makes use of a comfortable user interface, which the idea here on the bottom left is having multiple hands, which reduces the amount of arm movements that you have to make in order to interact with the virtual environment. The upper left you have also already seen in the other video is kind of something called Kinesphere. It has been presented at this conference, I think, last year or 2 years ago. And here the idea is that depending on where you put your arm, the menu is kind of adjusting to your arm location. So you always have the menu in some sort with respect where your arm is located, and you can rest it, and it might be just arranging around your wrist, around your elbow, or around your shoulder, depending on how you have your arms. And here on the right side, you see some sort of starting points for micro gestures of our group, in which you can use, for example, the Apple Watch to control your Unity environment, which is also pretty much inspired of something that Rob Lindemann and Mark Binet presented like 2 years ago, also here at the SUI conference, in which they attached like smartphone devices on the wrist with which you can interact with the virtual environment. And here on the bottom right, that's the ring shape device, which is featured with a joystick and also a touchpad and an IMU, so you can also use this for a kind of sort of micro gestures in order to interact in your space. So this brings us to the last aspect of the 3S of SUI, which is the smart part. So, and the idea of smart user interfaces is that they combine some sort of artificial intelligence with HCI for intelligent human-machine interaction. And with all the current algorithms we have in the area of machine learning, it seems pretty reasonable that we will see more and more artificial intelligence in our user interfaces. And we already observe that today, most dominantly in speech or language technology, in which machine learning really lead to a situation where we have a really good rate of speech understanding and recognition. However, speech itself is very slow for presenting information. It's also time dependent, so you cannot really revisit and edit, for example, what you said and worked with. And it also significantly interferes with other cognitive tasks. However, it's a very perfect example how machine learning can enhance the interface. And I think it's also interesting to see how ordinary tasks that we do in the real world get affected by these different paradigms. So how many of you arrived here by plane? So most of you. So what we have seen is in the 60s, you haven't brought your computer to the airport. Essentially, there was a command line interface in the travel office, and they printed your boarding passes and your tickets, and those were the things that you carried with yourself at the airport. Then in the 80s, we had graphical user interfaces, so you were able to print out your own ticket and bring it to the airport, and then you got your boarding pass and were able to get on the airplane. Nowadays, with natural user interfaces, you actually have your boarding pass and your ticket on your mobile phone, and you just go there with your mobile phone, it's going to be scanned, and then you can enter the airplane. And this is something we are currently, again, at the next paradigm shift, something I tried yesterday. It didn't work out too well, but in principle, you can use even your smartwatch now, and essentially more like a navigation system than rather just having a boarding pass. So it tells you how long it takes until you have to board, how many minutes it will take until you get there. It tells you where the gate is where you have to go, though. It also is kind of the boarding pass, which you can just put on the scanner, etc. And if we combine those more smarter user interfaces also with smart glasses, I think then the things are really getting interesting. So on the left side, this is a typical AR situation illustrated here that you can get at the airport. You will have some sort of head-up displays which give you some indications where you have to go, and then you have this 3D overlays of the environment telling you where you have to go. And using kind of the SUI concepts, I think these kind of navigation systems will pretty soon more look like this. So you still have your signs and your information, but they are more embedded in an intelligent way in the environment. So you might have like signs not really popping up at heads-up displays and occluding the view to the rest of the real world, but they are more attached to certain real-world objects, so something Steve Feiner would call it like world-oriented windows. And you could see maybe this board telling you where you have to go. Of course, only you see this on your smart glasses, and other people will see their information on their smart glasses. You get this navigation hints and also certain informations which kind of unsubtle or in a very unsubtle way guide you through the airport. And the smart thing at this point would really be if you just had basically a conversation or an email with your assistant that you say, hi, I want to go to SUI, and you just have this email, and based on this email, basically, you get automatically a boarding pass or at least a suggestion for the ideal flight that you could take, and automatically all this information might just be extracted from some sort of text data which derives from your email or from some communications that you had with your smart devices. And we just started a little bit in this area of smart user interfaces. So again, here are a couple of videos in which we try to combine HCI with some sort of artificial intelligence. So what you see here in the top videos are some projects from our human robotics interaction projects, in which, for example, essentially the human can give some rough indication to the robot what to do, like picking up this glass there, or here on the right side, picking up the mug, and the actual accurate grabbing of this object is done by artificial intelligence implemented in the robotic arm. So the humans just say, basically, give me the mug, and then the robot itself uses machine learning and machine intelligence, artificial intelligence, to grab the mug in the same way as a human user would do. Here on the bottom left side, this is a startup which evolved from our group, which is about augmented reality golf training. So the idea is that you get like the ideal putting line in your golf play, and you can use it as a projection setup for indoor golf training, but you can also use it outside using the Microsoft HoloLens. And here they also use nowadays a lot of machine learning in order to learn from the several thousand putts which people do with these devices now. And here on the bottom right, this is a project which also makes use of machine learning in order to improve the planning of constructions in the city of Hamburg. So the city of Hamburg is famous for the very bad situation that this is the city in which you spend most of your time when you commute in traffic jams. And so the idea is here again, use machine learning about historical traffic data, but also real-time traffic data from all the sensors that you can get in order to make good predictions how you should affect the traffic. So to conclude, I think these three aspects, supernatural, spatial, and smart, will get more and more important. And these are the three S of SUI, at least in which I have most interest currently in. And for the remainder of the talk, I would like to give like a brief outlook to the future of how these interfaces might evolve. So, as computer scientists, we have this wonderful exponential curve, which essentially describes since about 100 years how computer technology has evolved. Most dominantly, most of us will know that from Moore's law, saying like that computing performance doubles approximately every 18 months, which is based on the number of transistors which you can place inexpensively on an integrated circuit. But even before Moore's law and the integrated circuit, we had transistors or vacuum tubes or relays or electromechanical computing, and all of those technology followed this exponential curve. And according to people from Intel and IBM, Moore's law, or at least this double of computing power all 18 months based on integrated circuits will remain until about 2030. So at least the next approximately 15 years, we can be sure that this performance increase will continue. And probably afterwards, we will have the next generation of computing technology like quantum computer or whatsoever. So the good thing is, since this is like a valid curve for about 100 years, we can use this as a prediction how technology will evolve in the next couple of years. And just to show you again the milestones of the ultimate display. So we had Ivan Sutherland's introduction back in the 60s. 25 years later, we had the first commercial products, the first VR hype. 20 years later, this is where we are now. And so you see that the intervals are getting shorter and shorter. So I think it would be nice to just make a brief outlook of how technology might look like in 15 years, assuming that this technology curve will continue to grow exponentially. So doubling the performance every 18 months essentially means within 15 years, we know in 1.5 years, my computer will have double the power, the computing power that my computer has today. In 3 years, it's going to have 4 times the computing power that it has today, and so on until we end up like 15 years in the future. And this will result in a performance increase of the factor 1024. So 1,000 times more performance. And I think that's a really important message. If you think about if your technology will get 1,000 times better within the next 15 years than the technology that you have today, what does it mean for the certain applications that you have, for the data that you store, etc. And at least one thing I think is super interesting if you think about what does it mean being 1,000 times better in terms of computer technology regarding the ultimate display is the graphics Turing test. So how many of you have heard about the Turing test? I think this is pretty well known. So the Turing test, the idea is that you have a human user in front of a computer or in front of 2 computers, and he can communicate via text with the 2 computers, and behind one of the computers there is a real human user, behind of the other computer there is an artificial intelligence. And if the human subject is not able to detect where the actual human user is, then the artificial intelligence will have passed the Turing test. The graphics Turing test is inspired by this test, but the twist is here that it's about the realistic graphical representation. So the idea is that you have basically two screens, and on the one screen is a computer-generated virtual environment. On the other side is maybe just a picture or a real scenario, and if the user is not able to reliably distinguish which of the two is a computer-generated one, then this computer machine will have passed the graphics Turing test. Now you might think we have already solved the test, because if you watch, for example, a Hollywood movie, you cannot really tell what is CGI anymore and what is not. The goal is here to do that in real time. So think about you play a game and you're not able to tell if this is a game or if this is a video capture of a real scenario. And there were some previous work done by Michael McGuigan. They estimated that the amount of flops that you would need on your GPU would approximate about 0.5 to 1 petaflop of constant operations which your GPU should perform. And currently we are in the range of 500 to 1,000 teraflops, we are currently in the range of about 5 to 10 teraflops. So the current Xbox One has about 6 teraflops, which it can maintain on the GPU. So that means this is a factor of about maybe 500 to 1,000. So this is something that we will be able to achieve within the next 10 to 15 years. There we will be able to render a virtual environment which you cannot distinguish from the real world anymore. And here's just one reference how this will look like, being 1,000 times better in graphic representation. So I finished high school in 1996, and to be honest, I spent some time during high school playing computer games. So I played Tomb Raider, and Lara Croft back in 1996 when I finished my high school looked like this. So this was kind of the best rendering you could get back at that time. And now just moving 1.5 decades to the future, so about 15 years, being 1,000 times better, Lara Croft looked like this. Here, and if we just continue 2016, the last version of Lara Croft looked like this already. And this is like the in-game mode of Lara Croft. So we are already at a stage in which it looks pretty realistic. But just think about 15 years, we're going to be 1,000 times more realistic than this one again. And I think this really makes clear that at some situation in the future, in the next 10 years, we will not be able to distinguish between computer-generated content anymore and virtual content rendered, for example, on a head-mounted display. And I'm also pretty sure that this paradigm shift that we start to observe will also lead to the fact that the smartphones will go down. There will be less smartphones in usage, but we will see more and more smart glasses within the next 15 years or so of people running around. And I pretty assume that my son is going to laugh about the situations in which we walk through the street with a smartphone and our head held down looking in the small screen. And in Germany we have this combination of smartphone zombies, smombies. I'm not sure if you use that as well. And I think it's really time at some point to display the information where we actually need them, in our field of view, when we need them, at the location where we need them. And of course, the technology will also shrink and will improve, and at some point we might have form factors which look like contact lenses. And it's really interesting to see that all the big companies already have filled in their patents. Doesn't matter if it's Google, Sony, Apple, Microsoft, ODG, HTC, Facebook, all have filled in their patents on some sort of contact lens which is not only able to display information to you, but also to sense certain information from you, or also sense the environment by making constant videos, 3D reconstruction of what you see while you walk around. And again, this is not really science fiction, so there are already a couple of products and research products in particular out there which go towards this direction of having smart contact lenses. Already in 2011, Babak Parviz from the University of Washington presented the design, construction, and in vivo rapid testing of a wireless powered contact lens. And this lens was only able to display a pixel of 1, however it worked. The rabbit did not really suffer from the experiment, but on the other hand, it was also not reported if the rabbit thought it was a good idea to put a contact lens into his or her eye. But if we even take a look further to the future, at some point, this miniaturization of our smart devices will probably also continue and will evolve to some sort of BCI eventually, but we will also observe smart implants and smart pills. And to be honest, we already observe this already. So we see these first prototypes of implants of RFID chips, which you can implant in your skin. These are not really clever and they're not really smart, but essentially they allow you, for example, to start your car or enter your office or enter your building, or you can pay with them at some supermarkets and shops. And I'm just curious, how many of you have such an implant in your skin? Anybody here? Nick, you have? Okay. So actually, so Nicholas is currently in Hamburg, but I don't think that you have been in some of the currently what they call in Hamburg chipping parties. So employers basically pay for you the chipping, which makes it for them just less expensive and more convenient rather than providing the chip cards which you can lose or the chips which get stolen or something like that. So this is already cheaper and more comfortable, for example, for these small kind of tasks. But again, these are not smart chips, but they might get smarter and smarter in the future. And this also, again, extends the space of input that we observe, not only by having devices which are on your body, but also having devices which are in your body. So now we have also then at some point in body, in your space, and we might have the next paradigm. I don't have a good name for that. It might be IUI. There's another conference also called IUI, so that might not be a good name. But I assume that these interfaces are getting even smarter, so at some point they might be really intelligent. They're going to be invisible, and they also might be really implanted in your body at some point. So to sum things up, I think the next UE paradigms that we develop for this immersive technology of VR and AR should be supernatural, it should be spatial, and it should be smart. And I really like this conference and the acronym SUI, which kind of incorporates all these aspects I'm currently super interested in, although we haven't had in mind when we kind of founded this conference. So to the end, I would like to thank my co-authors and co-workers. This is a pretty long list, I realized yesterday when I was on the train. So I was thinking, with who have I worked in the last years? So I thought the best way to figure that out is going to Google Scholar and just list all my co-authors. So they are just ordered in the way how Google Scholar listed my co-authors. I have no idea how they arranged that. In addition, I would like to thank the funding agency and grants that we receive, and thank you all for your attention. Spatial. This is at least the one I'm most interested in. And of course, at some point, there's always like a combination of these S. So you cannot really work only on the spatial, but not really thinking at least a little bit about the naturalness or supernaturalness at that point. I think currently, if you really, I mean, to be honest, VR and AR is now in the consumer market. So it's going to be harder for us to really make a real benefit to this technology in terms of research, because there are a lot of developers, a lot of companies working on certain questions here. So for example, with my group just consisting of 15 people, we cannot really compete with Facebook, Oculus, the Vive, Google, or whatsoever with these companies. So, however, I think that certain aspects get more and more interesting if you just think about what will be like in 15 or 20 years. And I think like the BCI part, the implants thing is really interesting. And I think also currently a focus should be on having more smarter user interfaces and think about how we can use machine learning and artificial intelligence in our systems. I don't have any strong expertise in this area. I'm trying to find somebody from my group who is taking care of that, but I think that's going to be probably the most promising one if you make like a real benefit to the VR and AR technology, if you have more smart artificial intelligence included in your interface.
Maybe a follow-up question, if I might.
Sure.
I think that it's the exact opposite, that now that we have VR and AR around, we actually have the potential to do, or at least HCI-related research in a bigger dimension, because instead of focusing on getting the shitty technology to work, we actually can figure out what we can do with it, right?
Yeah, that's a good point. I agree. I just realized that I really liked the times, like 10 years ago or so, when I thought like, oh, that's a nice idea. And then I could go home, think about it, write something, made a first prototype, talk to some other people, rethink it again, re-implemented it, and at some point write a research paper. And nowadays, if I have the idea, I just Google it and then find, oh, some developer did that already. Oh, pretty cool. Yeah, it looks really, really nice how they did it. I can now try to identify why this is a very good solution, but I do not really have like the first thought of making this solution. And I think this is at least a little bit frustrating for me. But still, as you mentioned now, where we have this wide accessibility, we can really have like huge user studies and really see how certain things that we develop really impact not only our students or subjects which we recruited, but really the wide public. And we just started, for example, also to recruit more and more elderly people for VR. So we're doing a lot of Parkinson's studies, etc. So that's the first time we have subjects which are older than 60 in our lab, which is really interesting to see how they use VR technology.
Hi. As always, great talk, Frank. Could you talk, so a lot of this is really personal. Can you talk a little bit about how this fits in with collaboration? So oftentimes if I'm sitting around a table with somebody and I say, look, let me show you this thing that I'm doing, or come on, let me open my laptop and show you this thing. And it's great that all this works for me, but how do we make it work for us in terms of spatially working together, either in the same place or at different places? And I didn't really see it addressed, but I think it's really important that I think a lot of social media actually it purports to bring us closer together, but it actually brings us further apart. So it would be interesting to hear what you have to say about that.
I think that's a very important aspect, and that's why intentionally at the beginning when I talked about the sense of presence also added the social presence, because I think that it's really, really important. And as you mentioned, this kind of closeness of the head-mounted display kind of tears you apart from the other people around you. So I think that's very important. We just don't do, my group is not doing that many work in the collaborative aspects. That's why I haven't presented that much work on that. But of course, I assume that, I mean, if you just think about the two of us wear smart glasses, and of course we can see the same objects here at some point. I also, of course, can use this telepresence just to show a virtual representation of you close to me. And I think, I mean, at the end, it's pretty clear why Facebook bought Oculus. Facebook is the biggest social media company that we have, and they haven't spent $2.3 billion on Oculus because just for fun, but they think that this is like the next generation of how we actually communicate in a virtual environment together. So I think this will kind of naturally come at some point that these technology has to be used in collaborative aspects. And if I think about all technology that we invented so far was always claimed to hurt social communication and social contexts, but at the end only those technology which were really able to bring us closer together at some point really made it. And if you think about even like smartphones or the internet or emails, all these kind of things at some point where people were afraid of those because they were afraid that this will lead to the fact that we do not communicate with each other, that we do not visit each other. But at the end, they're all extended or augmented the way how we communicate to each other. So I'm pretty sure that this technology will do it in the same way, using virtual telepresence scenarios. We have smart glasses, can see the same virtual objects from different locations. You might be physically presented with me in an AR setup, and another person who's just virtually together with us, and with the three of us will interact as if we would be in the same place. So I think if this works very, very good, this is going to be the killer app for this technology.
So it would be good to see another S, social.
Social, that's good. Yeah. That's very good. Yeah.
I don't know if it's orthogonal.
Yeah, that's very good. Yeah. Thanks for the 4S of SUI. And I bet there are more. When I started the talk, I also had like sexy in mind or something, but social is better. Yeah.
Any other question?
Sorry, I'm still organizing the question, but when you draw the bubbles, like when you identify different categories of the interaction based on proximity, right? You draw the bubbles like evenly from all directions when talking about distribution, like even distance. But I assume, like from a personal experience, the boundary of the bubble might not be perfect spherical or like around us, like circles. Like for instance, like when people standing behind me, then I can tolerate them being much closer than people standing in front of me. Maybe the change can be so dramatic based on different directions. Like, what's your experience? What's your opinions based on the like? I'm assuming there might be some priorities in the directions rather than just evenly distributed, like perfect circles.
Yeah, you're totally right. So this was kind of a reference to Edward Hall's taxonomy of this setup. I essentially use these circles because they are much easier to implement in Keynote rather than having like different shapes. But of course, I agree. It depends on your orientation, for example. There is also different literature showing like different radii of the certain areas. So depending on what your current task is and what the situation is of people people standing there. So if there are multiple people or single people, Nicholas is working currently on robotics and thinking how does these spaces are affected by having robots with which you interact. So I'm pretty sure that they're not perfect circles. And I'm pretty sure they're also individually, they also depend on your ethnics, for example. So I realized, for example, I talked a lot to Betty Mohler, who's an American who lives now in Germany, and he said like she's always afraid how close people in Germany walk by each other, whereas in the US you're always like, excuse me, if you're just in the same office building or whatsoever. So of course they're not, to sum up, they're not perfect circles, I totally agree. Certainly aspects like your own orientation is a major rule, and I think this also, the orientation does not affect all these spaces in the same way, but probably like the public space is like really doesn't matter behind you at some point, so it's probably the field of view or something like that. And yeah, but that's an interesting question, how these shapes actually look like, and in particular how technology might also change these spaces.
Thanks. I have a question for you. So which advice would you give a student that wants to get into this area of research?
Okay, so yeah, I mean currently I just give them the if they come to my office, I ask them, hey, have you ever worked with Unity? So, I mean, this is really nice currently for the students. They really can work with this technology very, very quickly. So it just, I mean, we have kids in our lab from time to time, or we have Girls' Day, with which we have a couple of female users at the age of 10 to 12. It just takes an hour or so, and then they're able to build their own virtual environment and explore it with a head-mounted display at some point. So, however, I'm traveling a lot and giving a lot of presentation and talks, not only to research communities, but in particular to developers or companies, etc. And I think it's really important just to read the research papers. So there's a lot of research which has been done, and I think it has to be acknowledged at one point, and it also, of course, enhances the entire development process if you're aware of the kind of research which has been done. And of course, I'm telling all my students, go to the conferences. So here are the most interesting and most clever people who have worked in this area.
Thank you.
Yeah.
Right.
Thank you very much. Thank you very much. Your speech was very inspiring. I have a question, which is mostly an open question. So, looking at all this mixture of technologies which are having in the next years, I see that graphical interfaces nowadays are still on the way to be perfect. So my question is, how long it will take for usability of this new technology to be feasible or nice to use? So because there are a lot of very bad user interfaces. Mm-hmm. Yeah. So my question is about usability. What do you think about how difficult is now consider usability? Mm-hmm.
That's a good question. So regarding these intervals we had, it was about 20 years until we get to the next paradigm. So within these 20 years, obviously, we should make sure that we can use them very good. To be honest, I think we're not doing that bad for certain tasks. So if I just play like the current VR games or prototypes which are available, I think they work pretty well. So in particular, if you have the next generation which grows up with these controllers, they're pretty good in just grabbing some stuff and doing some things. And I think Alex Schwartz will talk a little bit about these intuitive interfaces and probably also about the usability. So I think actually that we're not that far away from really having some good VR user interfaces which are really, really usable. However, on the other hand, I think that certain tasks which, as you said, are optimized for the graphical user interfaces will never be solved that good in VR, at least not within the next 20 years, like editing a text document. So that works pretty well using the mouse and the keyboard, and it has been pretty much optimized for that. And I don't think that a VR interface can replicate this in a very efficient way, in such a way that you have a really performance gain compared to just use the mouse and the keyboard or spreadsheet applications or something like that. But however, as soon as it gets spatial, the mouse has its limitation for certain aspects. And as I said, I think a lot of the interfaces we have already a quite good usability. There's still some space for optimization, but I think it's really just comparing to what we had like maybe 10 years ago when the 3D user interface symposium was started, we were really kind of fighting, how can we select an object which is a little bit further away? Or how can we select something which is occluded? And I think that most of these things have really been solved by the research and now by the re-implementation of the developers.
So I want to, since it's a discussion, so I was just in London, and I had 4 good fortune to visit Anthony Steed's lab. So he's been working on all this stuff forever and ever and ever. And we have, we're over at the pub having a research discussion. One of the things that he talked about is, we all have tested teleportation and we know how bad it is. I mean, it's so disorienting and it's just really, you just don't want to use it. Actually, you do, right? So from his point of view, in the research domain, we tested this, it's terrible, it doesn't work, it's very disorienting. The game developers just implemented it, everybody loves it. They get over it, they get there, they look around, they said, this is actually really efficient, I can do this. But if we limited ourselves to just the group of researchers, it would be like, no, you don't want to do that. I myself have said that many times. I can't believe it. Anthony's like, teleportation's great. And for somebody like him who's been, again, banging on this stuff for so long, to just say, it's just really good for efficient movement, is really good. So from my point of view, we have so much to learn from citizen scientists because everybody has access to the technology now. So in some senses, it's not for us to decide because there'll be a lot of, the market will just say, this worked. And same thing with the GUI, right? So drag and drop works. And we can still do Fitts law studies about all these things, but it's going to be this nice dance between what the game developers come up with and other just kind of Joe and Josephine Sixpack who have a Vive setup. Build something, try it, put it out there, make a bunch of YouTube videos and say, wow, this is actually pretty cool. And then Frank's going to pick it up and do usability testing about, actually, it is more efficient than this or more acceptable, whatever. So it's a really beautiful time right now in that it really is, do you know Unity? Go pick it up and just start building stuff. And so it's actually, I would say, it's a good place to start is everything is just so accessible now. Just go and play. Find something that doesn't work well and focus on that as a problem, for instance, in VR. Like I'm looking for a research topic, immerse yourself for a decade or like a year about just using the technology and then say, this is really hard, even though I've been using this for a long time. That's probably something good to focus on. And that's a long, long thing.
Thank you for your presentation. So full disclaimer, I don't have a chip in my arm, so I was just kidding.
You have it in your brain, right?
So I really think that there is still space for us as academia. So we don't need to compete with Facebook or Oculus. They can make the new fancy stuff, but there is space for academia to systematize this knowledge and to find out why these things work and come up with the basic principles and the theories. So I wouldn't see it exactly that we need to compete directly with them. We can just work on understanding exactly why everything works.
Yes, I agree. It's not a competition. I think, as Rob said, it's like a collaborative thing, like a dance, how you phrase it. I think that's totally true. But however, as I said 10 years ago, I preferred that time by doing my research. And now it's just getting very, very quickly everything, right? It's like I cannot even just pay attention to what is going on in the market right now. So just if you look in the news and my Facebook account, it's full of, new head-mounted display literally every week, new device here, new application here. So it's just hard to basically understand and acknowledge everything which is currently going on in the market.
Hi, in the supernatural angle, you showed research in the circle getting smaller and smaller, the body being fooled more and more. Is the me rebelling? Is there elements of, the students when they take off the head-mounted display, one of the first things they say is like, it's so strange to come back to reality then. Is there evidence of people being disoriented that they've walked that much, the uncanny valley of spatial perception? Is that coming through, or are we easily fooled?
Absolutely. I mean, even if you do not really manipulate them that much. So as soon as you're done on the head-mounted display, I would say after maybe 10 or 20 seconds, if you don't get any cues from the real world, like sounds from a computer or so, you get disoriented very, very well. and very, very quickly. So that if you're done on the head-mounted display, you have okay, now I'm standing here rather than in the virtual world on the corresponding space. And this is, of course, even more true if you start to manipulate the users. But as I said, in most situations, you're disoriented anyway as soon as you have that head-mounted display and move around a bit. So it's not really like that we observe that if we have manipulated them, they take off the head-mounted display and we're like super, super surprised by a different space. Than if they have the head-mounted display anyway. And in most of the experiments, I think in all the experiments, they will see the physical lab before. And to be honest, in most situations for the papers that we did, this was really like a psychophysical study. So the distance that they walked was like 5 meters, and essentially they walked like 100 times these 5 meters back and forth, and we used different manipulations, and they were asked to determine if they have been manipulated or not. So it's not like that we bring them in a very dark room and then get the head-mounted display, and then they walk and have the impression that this is like a very huge space, and then we turn on the light, it's very small. That would be interesting to do so, but we haven't really have the space available to do so. Yeah. But there are some commercial products out now, like the Void. I'm not sure if you have tested that. There are a couple of installations around the world, and I just tried one on my way back from Rob Lindemann from New Zealand in Dubai. So there was one installation of the Void in which you can play Ghostbusters. And you can walk around and shoot kind of the ghosts flying around, and you have like multiple rooms which are connected. I'm not sure if they actually use redirected walking in that installation, but they use redirected walking in other installations. And unfortunately, they haven't let me really see the system, so I only could see a glimpse of the actual setup. And even as an expert, I would say in redirected walking, for me it's always also not hard or not easy to detect if I'm getting manipulated or not, and even if you know that you're getting manipulated. So there is a certain amount of disorientation that you will get anyway, and it doesn't really matter if you get manipulated in addition by redirected walking.
So we need to move on. So
Thank you. Thanks for the question.